Hey everyone, I'm Julia, and today I have a quick question for everyone. Do Surds ever make you want to pull your hair out? And I mean literally pull your hair out. Because they sure make me feel like that, and I'm sure that's not a great feeling to have, especially if you're already stressing about exams. So today I'm going to show you 3 super quick tricks to make Surds way easier, and I promise by the end they won't look as terrifying. Oh yeah, and I've popped a few timestamps below, so if there's any particular Surd driving you completely insane, just feel free to jump straight to it. Okay, so the 3 topics we're going to be tackling today are simplifying Surds, rationalising the denominator, and adding and subtracting Surds. So let's actually get started. So simplifying Surds is that one thing that pops up all the time in exams, and it always looks much harder than it is. However, in reality, it's one of the easiest things to solve in maths, once you know how. Let's take root 50 for example. At first glance, it looks really messy, and it doesn't really look like you can do much with it. But here's the trick. Always look for the biggest square number hiding inside. So, what do I mean by this? 50 has a 25 inside it, right? Alright, so 50 does have a 25 inside it, but you might be thinking, how does this even relate to the question? Well, since 50 is equal to 25 times 2, root 50 must be equal to root 25 times root 2. Since 25 is a square number, you know that root 25 can be simplified to just 5. And root 2 can remain as root 2. So, putting all of this together, we've got root 50 is equal to 5 root 2. And boom, we're done. Root 50 is simply 5 root 2. I'm sure you're all thinking now, if only all Surds were this simple. Well, I've got good news for you. They really are. All you need to do is always look for the biggest square number that can fit into the Surd you're trying to simplify. Don't believe me? Let's try this on another example. Okay, so now let's look at root 72. Let's remember, we're always looking for the biggest square number hiding inside. So feel free to pause the video and come back and check if you got it right. Alright, welcome back. I hope you've got the answer. So let's tackle this question. Okay. The biggest square number that will fit into 72 is... Yep, 36. So let's go ahead and write root 72 is equal to... Oh, if my pen decided to work. Let's try that again. Root 72 is equal to root 36 times root 2. And I'm sure we all know that root 36 can be simplified to 6, and root 2 will remain as root 2. So what's our final answer? 6 root 2. Easy peasy, and our trick works again. So if you still don't believe me, go ahead and try a few more examples that I've popped into the description of this video, and then come back and tell me that I'm wrong. Okay, in the meantime, let's move on to trick number 2. Okay, so next up we've got rationalising the denominator. I've noticed that a lot of people love to make this topic sound really complicated and scary. However, all it really means is just don't leave the Surd on the bottom of the fraction. So let's see what that means in practice. So for the first example, we can look at 1 divided by root 3. Alright, so here's the trick. Multiply the top and bottom by root 3. And I know that's really underwhelming, but that is literally all you need to do. So the top of the fraction, that will give us 1 times root 3 divided by root 3 times root 3. And that will simplify to root 3 at the top and 3 at the bottom. Also, the reason we get 3 at the bottom is if you do root 3 times root 3, you'll end up with root 9. And that can simplify to 3 as 9 is a square number, so it will just simplify. Okay, so now I've got a quick test for you. What about 5 divided by root 2? So again, pause the video, have a go, and come back once you've got an answer. Okay, so now that everyone's back, all we're going to do is multiply the top and bottom by root 2, which gives us a final answer of 5 root 2 at the top and 2 at the bottom. Now onto the last trick. Alright, trick 3. Adding and subtracting Surds. So this is usually where people panic, but think of it like collecting apples. Stick with me now. For the first example, let's try 2 root 3 plus 5 root 3. That simply gives us 7 root 3. Because they both have root 3 in them, which means they're the same type of Surd, so you can just add them together like normal. So think of it as if root 3 is representing apples. But now watch this. If we do 2 root 3 again, however we do plus 4 root 2 this time, can we combine these? Nope, because they're different types. And what I mean by this is we've got 2 different types of surds. So in the first part we've got root 3, and then in the second we've got root 2. So think of root 3 as being an apple, and think of root 2 as being a banana. Which means they're just different types of fruits, so you can't combine them. Fruits, surds, kind of the same thing, but you get the gist. So let's remember, you can only add or subtract surds that match, either 2 apples or 2 bananas. So for the final example, let's put all the tricks we learnt today into one question. Alright, so for the final example, let's say we've got root 50 plus 2 root 2. So for the first step, let's simplify root 50 into 5 root 2. So now our equation looks like this. We've got 5 root 2 plus 2 root 2. And so now since both parts of the equation have the same surd, root 2, we can simply collect like terms, which will give us 7 root 2. And we're done. So I know surds can seem pretty daunting, especially at the start. However, once you know the rules, it's just like normal algebra. You apply the rules to the equation, and before you know it, it's solved. And that's about it. 3 quick surd tricks every single GCSE student needs. So to summarise, trick 1 was simplifying using square numbers. Trick 2 was rationalising the denominator. And trick 3 was only adding or subtracting like surds. And that's it everybody. If this video helped, don't forget to hit subscribe so you don't miss the next lesson. And let me know in the comments which GCSE topic confuses you most. Thanks for watching, you've got this.